So the follicular phase, the phase that accomplished the growth of the follicles and eventually ovulation, is now over. Once ovulation has occurred, we're in the luteal phase. It's called the luteal phase because it's about the development of this orange structure here called the corpus luteum. The corpus luteum, it's what's left over after an egg has been expelled during ovulation. It's the remainder of the follicle. What happens next, as always, depends on the levels of our various hormones. So let's look at what's going on with them. We've just had the luteal surge. So at this point, LH is really high. LH and FSH together are going to encourage the follicle from which the egg was released to turn into this structure, the corpus luteum, which is Latin for yellow body. It's drawn in orange here. Remember that the follicle was what caused estrogen to be released from the granulosa cells. But since it's not a follicle anymore, the amount of estrogen drops down significantly. We can see that here. Instead, the corpus luteum begins to produce progesterone. We can see that on the graph here in orange. Progesterone, the word actually means for gestation, and it's the essential hormone for the second half of the cycle. Once ovulation has occurred, there's a chance that the egg could be fertilized, and if fertilized, it will need a place to implant. So the task of the luteal phase, accomplished mostly by progesterone, is to prepare a nice vascular lining of the uterus so that the fertilized egg can implant there. It's now called a blastocyst and soon will be called an embryo. And that way it has a place to implant and grow. How does progesterone accomplish this feat? It increases blood flow to the endometrium by stimulating the development of special arteries in the endometrium called spiral arteries. They're shown here in red. You can see them here in the uterine lining, and these arteries will eventually allow the embryo to have good access to nutrients from the mother's bloodstream. Progesterone also increases uterine secretions from special glands in the endometrium, hence the term secretory phase, and these secretions are important for the nourishment of the embryo. Finally, progesterone actually reduces the contractility of the smooth muscle of the uterus. Remember that the uterus has a lot of smooth muscle in its walls. Progesterone decreases the ability of these muscles to contract, ensuring that the growing embryo doesn't get too disturbed or get dispelled too early. While the corpus luteum is producing all this progesterone, it's also continuing to secrete a little bit of estrogen. Together, these two hormones will again provide negative feedback to the hypothalamus and the anterior pituitary to suppress the production of LH and FSH. You see how they dip low here when estrogen and progesterone are very high? And don't forget about inhibin, which is also being produced by the corpus luteum. That's the one here in blue. You can see it peak when the corpus luteum reaches its maximum size. So that's also helping to suppress LH and FSH. Unfortunately for the poor corpus luteum, it needs FSH and LH to survive. So it begins to atrophy and to die, prompted by its own hormone release. Remember that the corpus luteum was responsible for producing estrogen and progesterone. So when it begins to atrophy, the estrogen and progesterone levels begin to drop off over here. When that happens, menstruation occurs and the lining starts to shed. We're back here at the beginning of the cycle. Remember that on day 28, we're also on day 0 of the next cycle. So we're back here to the beginning at the follicular phase. And menses occurs at the very beginning of the follicular phase of the next cycle. So menstruation is a sign that pregnancy has not occurred. It can last 2 to 7 days, and women usually lose around 40 milliliters of blood. Remember also that once estrogen and progesterone drop here at the end of the luteal phase, they stop exerting their negative feedback on the hypothalamus and the anterior pituitary. So FSH and LH can begin to rise again in the next follicular phase. The increased FSH goes on to stimulate follicular development, and the whole cycle occurs again. Bear in mind that everything I said about the corpus luteum atrophying and dying is true only when there is no pregnancy, which is the case in the vast majority of reproductive cycles. But what happens when there is a pregnancy? When a blastocyst implants, the embryo begins to produce yet another hormone, HCG, or human chorionic gonadotropin. This is the hormone measured by most pregnancy tests because it doesn't exist if there's no pregnancy. HCG is structurally very similar to LH, so much so that it can take the place of LH in keeping the corpus luteum alive. If the corpus luteum does not atrophy and die, it will continue to produce estrogen and progesterone, and that uterine lining will continue to grow. The corpus luteum will continue to produce progesterone during the first couple of months of gestation, while the placenta is being built. After that, the placenta takes over. For more information about the physiology of pregnancy, look at our Pregnancy 101 self-study PowerPoint, also included in this module.